So, when it comes to static analysis tools for Python, have you looked into any specific ones yet?
I've been looking at Pylint and Flakate mostly. They seem pretty standard.
Absolutely. Those are good starting points. Pylint can be quite verbose though, right? It catches a lot, but sometimes it's too much.
Yeah, especially with large code bases. It can get overwhelming.
Exactly. That's why configuring it properly is key. You know, setting up your own RC file to tailor the rules to what really matters for your project.
True, but that takes some time to set up initially.
Sure does, but think about the long-term benefits. Automated checks catching issues early on saves a ton of debugging later. Speaking of which, have you ever had a case where static analysis caught something you wouldn't have noticed otherwise?
Actually, yeah. A few times. Like this one instance where Pylint pointed out an unused import that was causing confusion in our tests.
Z? That's exactly the kind of thing these tools excel at. And let's not forget about security vulnerabilities. Something like Bandit could come in handy there.
Right, I'll need to check that out then.
Definitely Bandit is great for security. But let's circle back to Pylint since you mentioned it earlier. Have you customized the rules yet? Or are you running it with default settings?
I've been using the default so far just to see what it flags without any tweaks.
Gotcha. Gotcha. Starting with defaults is a good approach. It gives you a baseline understanding of how strict or lenient Pylint is out of the box. Then, from there, you can start fine-tuning based on your project needs.
That makes sense. What kind of customizations do you usually make?
Well, first, I often disable some warnings that aren't relevant for my projects, like certain complexity checks if they're too stringent for my use case. Also, setting up message control to categorize errors and warnings helps manage the output better.
Disabling irrelevant warnings sounds useful. How do you decide which ones to disable?
It depends on the project and team preferences. For example, if your codebase doesn't benefit from enforcing specific style guidelines, disabling those rules can reduce noise. Plus, having clear documentation within your team about why certain rules are disabled ensures everyone is aligned.
Clear documentation would definitely help avoid confusion down the line.
Absolutely. And don't forget about integrating Pylint into your CI/CD pipeline. That way, every commit gets checked automatically, ensuring code quality stays consistent throughout development.
Integrating it into CI/CD sounds like a good plan. Any tips on doing that smoothly?
Start by configuring Pylint in a separate step before building or testing steps in your pipeline. Make sure to fail builds when linting fails if that aligns with your team's goals. Also, keep an eye on performance. Large repositories might slow down the process.
Performance is definitely something to watch out for then.
Exactly. Oh, and speaking of performance, have you ever tried running Pylint on a huge code base? It can take quite a while sometimes.
Yeah, I noticed that once. It was a bit slower than expected.
There are ways around that though, like breaking down the analysis into smaller chunks or using incremental analysis features if available. Speaking of static analysis, have you explored using my for type checking in your Python project?
Not yet, but I've heard good things about it. How does it fit into the overall static analysis workflow?
Great question. MIPI is fantastic for catching type-related errors before runtime. It can integrate seamlessly with tools like Pylint to give you a comprehensive view of potential issues in your code.
That sounds really useful. How you typically set it up?
Usually you start by installing MyPy and then running it against your codebase. Adding type annotations to your functions and variables helps MyPy catch more issues. Over time, you can incrementally add more annotations to existing code.
Incremental addition of annotations seems manageable. Does it require significant changes to existing code?
Not necessarily. You can gradually introduce type hints where they make the most sense, like in new modules or critical parts of the codebase. The goal is to improve readability and maintainability without disrupting ongoing work.
Gradual introduction makes sense, especially for larger projects.
Definitely. Another benefit is that MyPy can be configured to run as part of your continuous integration (CITES). This ensures that every change is checked for type consistency before merging.
Running it in CI would certainly help maintain code quality.
Absolutely. And don't forget about the community support and extensive documentation available for MyPy. If you hit any roadblocks, there's plenty of guidance out there.
Community support and documentation sound reassuring.
They are indeed. Plus, MyPy supports both dynamic and statically typed workflows, making it versatile depending on how strict you want your type checking to be.
Versatility is a big plus, especially when working on different types of projects.
Exactly. Have you considered adding MyPy to any of your current projects? Speaking of static analysis tools, let's talk about Flake8. It's great for both code style and error checking in Python projects. Have you used it much?
I have, but mostly for basic linting. What are some advanced features or configurations you recommend?
Good question. One thing is to use plugins with Flake8. For example, Flake8 Bugbear finds common bugs that aren't caught by the core Flake8.
That sounds helpful. Are there other plugins worth considering?
Definitely. Flake8 docstrings is great if you're working on a project where consistent docstring formatting is important. And McCabe can help detect complex code structures that might be simplified.
Those sound like they could be really useful additions.
Absolutely. Configuring Flake8 to suit your project's needs is also crucial. You can customize the rules in a Flake8 configuration file to ignore certain warnings or enable additional checks.
Customizing the config file makes sense, especially for larger teams.
Exactly. Plus, integrating Flake8 into your development environment can enhance productivity. Many IDE and text editors have built-in support for running Flake8 as you write code.
Real-time feedback would definitely speed up the development process.
Indeed. And don't forget about using Flake8 alongside other tools like Pylint or MyPy for a more robust static analysis setup.
Combining them could provide a comprehensive coverage of issues.
Right. Each tool has its strengths, so leveraging them together can significantly improve code quality and maintainability. Have you ever configured Flake8 to work specifically with virtual environments?
Not yet, but I imagine it could be useful for project-specific settings.
It can be very handy. Setting up a separate virtual environment allows you to install specific versions of plugins and configure them independently for each project.